So welcome to the session on safe handling and management of end-of-life batteries. You have two great speakers this afternoon. Unfortunately, we've had a little bit of difficulty. We're starting a little bit late. We don't seem to have a clicker for PowerPoint presentations, so you bear with us and the speakers as we try and do the presentation without a clicker. But I wanted to tell you that, as you all know, that batteries are everywhere and more are coming. And what's the good news is both of these people have solutions for us to help us. I mean, everybody wants to know, what do I do with them? Do I want them? Where do I take them? What's reasonable? Is it cost effective? Is it safe? Lots of questions surrounding batteries, and we're really coming up with some answers with these two speakers. So I'll introduce them to you. Chelsey Schneider is a career firefighter for Worthington, Ohio. She's certified rescue instructor, a technical rescue specialist, a fire instructor, firefighter number 2, an EMT. She's also a member of the Rescue Methods team, an international technical rescue trainer, and a participant in the Global Rescue Competition and Consortiums. Schneider is also the director of training for the Energy Security Agency. ESA is an international leader in the fire-based research, testing, training, and consulting related to energy storage and lithium-ion batteries. So let's welcome Chelsey to the stage.
Good afternoon. How's everybody doing? Good. All right. Can we start the PowerPoint back there? Thank you. And like she said, bear with us a little bit. Unfortunately, usually I'm up here with my clicker. I also usually paste with that clicker. So, we'll work through it. So, like she said, my name is Chelsey Schneider. I'm our director of training for Energy Security Agency. So what we do is basically we are a rescue consortium that about 15 years ago got approached by, FDNY to come and help with some battery burns. At the time, we had no idea what we were getting into when they asked us to come and be basically their battery people and just like kind of oversee these tests and everything like that. But through that testing that we did over that year with FDNY and ESRG, our partners, we became one of the largest large-scale battery test groups in the world. So ourselves and can you click on to the next slide? Ourselves and ESRG for the last 15 years have been running one of the largest lithium-ion battery test sites. So we do everything from large-scale testing of giant Connex containers like you see to small-scale testing like the little battery pack that you guys saw outside. We do everything from testing the gases that come off of it. We test the fire. We test fire gear. We test the water in the runoff. We test what works, what products work to put it out, what products don't work to put it out. And we take all this training and we go out and we do teaching. We teach anybody from firefighters, police officers, the recycling industry. We also now teach auto dismantlers. We also have started getting into the auto dismantling side. A couple of years ago, we actually hired a group of engineers who have started teaching different auto dismantlers how to drop battery packs, how to dismantle battery packs, and all of those things. And through that, we've kind of grown into this company that you see up there. Go ahead, next slide. So today, I'm going to talk to you guys about your challenges specifically in the recycling industry. One of the biggest challenges that you guys see on a day-to-day basis is what we call micromobiles. When we talk about all lithium-ion batteries, from micromobiles to your hybrids and electric vehicles to large fixed systems like you saw on that screen, it's all the same battery, right? You're thinking of a battery that has 5 different components. It has an anode, a cathode, a separator, electrolyte, and then a casing that encompasses it. They all will react in the same type of reaction when you start talking about off-gassing, you start talking about the fire reaction, all of those things, just basically on a bigger scale when you start like making it bigger. So for you right now in the recycling industry, micromobiles seem to be the biggest thing you're facing. People are leaving laptop batteries in their vehicles, right? People are leaving cell phones, all those things. And how do we figure out where they are? How do we know where they are? Part of that is doing a good inspection, but part of it is also knowing what happens if something goes wrong with one of these. And I'm going to talk about that a little bit at the end and show you some different videos so you can make yourselves aware of what to do if something happens. So what I want to show you here, this is our first video that we have, and I'm going to have lots of other videos from our test site, but this video is just showing basically a little charging device that gets dropped right by a scooter. I promise everybody gets out of this elevator in the video, or else I wouldn't show it to you. But what I really want you guys to see is the large amount of off-gassing. Has anybody here ever heard that LFP batteries are safer? Anybody heard that chemistry safer? Actually, it has about 5 times the amount of off-gassing than a normal battery has. And this is actually an LFP battery, and you'll see how much off-gassing encompasses that entire elevator. I want you to think of the confined spaces in your area. If you have one of these batteries that gets dropped, or you have a forklift battery that goes into thermal runaway, anything like that, you're going to have large amounts of off-gassing. This off-gassing is high in CO, high in hydrogen, and is super toxic to inhale it. So we'll talk a little bit at the end about what that means for you, but go ahead and play this video. So it's not this scooter that comes in. This is actually not an electric scooter. But I want you to watch when this woman comes in right behind him. And she drops this little tiny battery charger. And 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. That entire elevator is completely filled with that gas, that off-gassing that we're talking about. Like I said, super toxic, highly flammable, highly combustible. So right now, I want you to see once this goes into full thermal runaway and actually is all the way engulfed, that atmosphere actually becomes a lot better. So when we start talking about putting out these batteries at the end, we start talking about what works, what doesn't work. A lot of people will push certain different types of foams, things like that for you to purchase at your sites. I will tell you, nothing works as best as water. There are a couple products that you can use to quickly stop that off-gassing and actually be able to save the people around or save the space around until the fire department gets there. But foams and things like that, they're going to encapsulate that, and they're actually going to end up producing more off-gassing at the end. All right, next slide. So the next challenge for you guys is going to be anything from all electric vehicles to hybrids to plug-in hybrids. And this is just a great comparison of the 3 different types of vehicles. This is what's called an ERG. If you've never heard this term before, get with me after this. So an ERG is an emergency response guide. Every vehicle that's sold over in Europe is required to have one of these. This will show you where all the high voltage components are in the vehicle. Okay, this is great for you, especially if you're deciding if you're going to take these vehicles, or if you have one of these vehicles in your lot and it has damage to that vehicle. If there's potential for anything bad to happen, you want to know where these high voltage components are, because if there's some type of damage around that battery pack, around onboard charger, anything like that, you have a high likelihood of that vehicle catching on fire in your lot, and you want to make sure you're storing that away from anything that's potentially going to be flammable or any structures that you might have. Like I said, these are called ERGs, but this is just a side-by-side comparison of an all-electric vehicle to a hybrid to a plug-in hybrid. You see that battery just gets smaller as we go along. Next slide, please. The next challenge that you guys may face, not a lot of recycling industry is getting these right now, but this is called fixed energy systems. This is the same battery types you're going to see. A lot of these are going to be LFP batteries, but this is basically a fixed storage system that just collects energy from the grid, and may store it for a company, may store it for a hospital or anything. The big reason I talk about this here for you is a lot of sites we're seeing, like especially bigger companies, are starting to have this on site. This is something that if anything starts happening with this fixed energy system, you want to make sure nobody is anywhere near that, because these are highly, highly dangerous. Next slide, please. And next slide. All right. So when we talk about safety and we go around talking about safety to different industries, I want you to use your 3 senses. We're not going to use taste. Don't worry. I don't want you guys looking any of these batteries. So we want to look for sight, smell, and sound. So when we're looking at a battery we take in, even if we're taking it in as we first take in a vehicle, as we first take in anything that might have potential, we want to see if we see any smoke, any fire, obviously, but any deformities to that actual vehicle itself. So like I said, those ERGs are super important, just to know where the high voltage components are and to know if it has risk for it having potential damage to a high voltage component where it could backfeed in that battery, or you might have to do some type of secondary shutdown. Obviously, arcing, smoke, and gas are very obvious signs that something might go into thermal runaway. The next thing we're going to talk about is smell. And when you're doing constant like evaluations of those vehicles while they're in your lot or while they're in your area, you want to train your people to smell for what Tesla calls a sweet cherry bubblegum smell. I think it smells like an electrical like ballast burning with like a Jolly Rancher in your mouth. That's like kind of the best comparison I have. But you'll smell that. And once you smell it once, you'll definitely like smell it over again. Was anybody outside for the burn just now? Did any of you guys smell that sweet odor? It's very, very distinct. So, the last thing you're going to look for you're going to check for is sound. So you're going to listen for buzzing, popping, hissing, any of your normal electrical sounds. This is going to be an indicator that something might go wrong in the future. Next slide, please. Okay. Keep going. All right. So potential dangers of these different batteries. Like I said, the off-gassing is highly conductive. There's a high arc potential, and you can have stranded energy in that vehicle as you intake it. The off-gassing is also highly toxic, very high in hydrogen, CO, CO2, also a little bit of HF, right before combustion. And then it's also highly flammable as well. So obviously, lithium-ion batteries are dangerous, but these are just things to train your people on. These are the dangers and potential things that you can come across. Next slide, please. Okay, so what I'm showing you guys here is this is called what we call a puncture test. So this is a grouping of 8 18650 batteries. They're little cylindrical batteries, kind of like the ones you saw outside, but there's 8 of them bunched together. And what we did in this test is we actually took a nail pin into the battery pack because we wanted to see how it would react, how forceful it would be. I believe this is at a 60% state of charge. What I want you to watch is the instant reaction, but there's also one battery cell that gets kicked off about 10 feet away, and you'll see that it ends up going to the thermal runaway about 2 minutes after this. You'll hear almost that hissing sound, and you'll see a pretty good torch flame coming out of it. So go ahead and let's start that video. You look right behind it, you see that second battery starting to go off. And the same off-gassing that you saw outside, not as much of it produced, but high potential. And then in this scenario, we actually did have a battery go about 80 feet off to the side. It actually never went into thermal runaway. So one of the things we asked a lot from our partners, if I do have an incident, what happens if I have batteries start to scatter everywhere? What do I do with those individual cells that are everywhere? Once they go into complete thermal runaway, I mean, they're just regular waste. But I think Eric's going to talk about that in a little bit, but there is a certain cleanup procedure you're supposed to have. You actually should have somebody who's trained in that, looking at those. And when you're inspecting, you have to make sure that you're not like just dumping ones that haven't like gone into general waste, which people often do. Go ahead and kick the next slide. So, 2 tools that we always tell everybody to have on hand if you're going to start dealing with lithium-ion batteries is a 4-gas meter, or at minimum a CO detector, because that's going to have early detection of something going wrong. On a normal all EV or even a hybrid, you're not going to have high levels of CO. Once these start going to off-gassing, you're going to see 50 parts per million or more on your CO reading. You'll also have cross-contamination on the hydrogen side. So a 4-gas or a CO meter is something, if you're intaking these, you should have on scene, or on your site and somewhere around whatever you're intaking. The other one is a thermal imaging camera. I have a lot of companies come up to me and tell me they use like a heat detector or a heat gun. The problem with that is a lot of the times you're not going to see heat difference change in these when something happens early. A thermal imaging camera is actually going to show you the off-gassing before anything ever starts. So this video is actually the same battery, just 4 different images. The bottom corner over here is actually it going, in the thermal imaging camera, the video of it in the thermal imaging camera. Go ahead. So you can see with your naked eye, you can't see any type of off-gassing starting, but you can see early detection. And this is the same on vehicles. This is the same on your little micromobiles. Even the same, we use this on our fixed energy systems where we go to do cleanups. We'll see early off-gassing starting before we see anything with our naked eye. You will also smell it very early on before you see it at all. So go ahead and click the next one. All right. So what are some solutions? What are some solutions you can have at your site to make yourself safe and make sure that if there is an incident, that it doesn't go beyond where it is? First of all, if you have any type of off-gassing, if you have any type of fire, anything like that, like I said, it's highly toxic, highly combustible. You want to make sure that your personnel, if they're not trained, are not anywhere near that vehicle, that battery pack, anything like that. So we always tell people 75 feet away. If you have to, and you have to do something to save your property or save the vehicles next to it, there are a couple different solutions. One of them is a fire blanket. Now, a fire blanket is not really supposed to be put on by anybody who's not in an SCBA, but if you own the company and you want to protect the things around you, this might be a last minute solution. I will say not all fire blankets are equal. Definitely you're going to pay for what you get. And I can talk to you on the side if you have any questions about that. But this is just the deployment of a fire blanket. This was us at a fire training, just showing how to correctly deploy it and put it over the vehicle. And like I said, this is just a last minute solution. Go ahead. So you see they get it all the way over the vehicle and then they almost tuck it under just a little bit. Now, this is not going to completely put out the fire. What it will do is temporarily stop the fire until the fire department can get there. You will still have off-gassing underneath this blanket. And this blanket every couple minutes will do what's called burping. So it will kind of burp out that off-gassing. So this combined with water is usually how we end up putting out a fire if we have to on these vehicles, if they're near any type of structure. So this is a product that you can have at your site to be able to temporarily kind of save things around it until the fire department can get there and pull the vehicle away from whatever. Next slide. Another one is submersion. There are a couple companies that sell these submersion tanks. Now, depending on where you're at, this can be a little bit iffy with different aspects of your EPA rules and everything like that, what you can do with water and everything like that. This does have to sit in this tank for about 30 days to actually be a solution. While I wouldn't recommend this as your first choice, there are companies that are out there that are doing this. Go ahead and next slide. And then if you have an incident, and Eric's going to talk about this a lot, you need to make sure that you have the right people cleaning this up. There are people who are trained in how to clean this up correctly. Not every environmental company is actually trained in this. You have to make sure they have a 49 CFR, are able to ship it in the correct way, and are able to package it in the correct way. I believe he's also going to talk to you guys a little bit about different products that you can buy and have on site if you have a small battery, and you have to put it in something until you can get that shipped or moved from your location. In our class that we teach with ReMA, it's called the EV Safety Technician class. It is basically a training on site management, how to intake vehicles, and then we also go over how to actually pack a battery in this if that's something you're going to be intaking. If that's something you want to do where you guys are going to be taking apart batteries and actually shipping them off to your other recycling partners, we actually do teach that in our class. Our class also does teach how to take out a battery pack in that class. So we have that class, and then we also have a EV dismantling class that is specific towards the recycling industry. Next slide. So if all else fails and you guys have an emergency situation, we also do have a 1-800 number that's completely free. It was first, we made it originally for first responders, but we've now reached it out to the recycling industry. If you guys have an incident, if anything happens and you don't know what to do, this is always the number. If you need more information on how to manage your site correctly, how to set up your intake or anything like that, call our number and we'll help you out. So, and I believe that's all I have. So thank you very much for listening to me. And next one.
Don't you have a booth?
Oh, Also do have a booth outside. Please come see us, talk to us about all of this, and if you have any questions about intake or anything like that.
Thank you, Chelsey. So the next speaker is Eric Frederickson. He is the Vice President of Operations for Call to Recycle. Eric is responsible for the organization's supply chain, safety, compliance, downstream recycling network. This includes optimizing performance and efficiencies while upholding the organization's commitment to safety standards and compliance obligations. Eric's day-to-day focus is on helping a variety of stakeholders understand and address the unique safety and environmental challenges associated with lithium-ion batteries. With that, welcome, Eric.
Thank you. All right, hey, gentlemen at the front of house, I've got the whole thing where my bullets appear, so it's a lot of stuff to go through. So I'm just keep an eye out for, and thank you. Okay, so we got a couple of people here. Thank you, Danielle. We got a couple of people here who I know and recognize who intentionally bring batteries into their facility, right? So, our partners at CERBA are here, and Ascend and Critical Materials and RCI. We have some folks from Australia who collect on behalf of B-Cycle, the Australian recycling scheme. Here's something for everybody to know. Regardless of whether or not you think you are a battery recycler, if you are a ReMA member and you bring anything onto a yard, if you have a yard, you are a battery recycler, whether you want to be or not. So it's really important to get smart on this. There are rejection protocols and there's non-conforming material, but none of that changes from a practical standpoint what you need to do. All right, so maybe this is what you think of as a damaged battery. Or maybe this swollen, bloated battery is what you think of as a damaged battery. Maybe you think of something that's already been to the thermal runaway, has been physically abused. This is a damaged battery. Right? Maybe, okay, now we have things that are burning and melting. These are damaged batteries. All right. These are damaged batteries. Now, this is not a flatbed. If you take a look, you can actually see the rear portion of this dry box. This was a shipment of batteries shipped by a battery recycler. So somebody who conceivably knew what they were doing with this. All right. So it was at a Flying J truck stop in Alabama, and one of the drums, 55-gallon drums, that would be a 200-liter drum for you, Doug, went flying about 30 feet into the Flying J truck stop. So you can see here a variety of drums. This is what damaged batteries are. So this is the side of the road of a shipment of batteries. So this is what damaged batteries are. This right here, this is a facility from a battery recycler that had the most advanced battery fire suppression and risk mitigation technology that is available on the market. So that's a $200,000, 200 square foot facility. So Jerry asked me to speak on three things: handling and storage, regulatory requirements, and packaging. So we got a fair amount of stuff to go through here. First off, I'd like to go through who we are. Call to Recycle, who I work for, is a nonprofit. We were founded in 1994, so we've been doing this for over 30 years. We have over 16,000 collection sites. 90% of the U.S. population lives within 10 miles of one of our collection points. We provide extended producer responsibility compliance solutions for battery producers. So if you've got something, so if you are covered by if you make batteries or battery containing products and you're covered by some of the state level regulations to fund a recycling program, we help manage those. But we also do a lot of work in the B2B space, providing, coordinating with ESA, for example. We do emergency response work. We work on recalls on behalf of OEMs, and then we're increasingly doing a lot of EV and ESS logistics. Last year, now these numbers are small by ReMA numbers, right? We're not talking about like tens of thousands of metric tons. We collected about 9.8 million pounds of batteries, one battery at a time, from consumers last year. All right, so handling and storage. What does that actually mean to handle and store batteries? Handling and storing batteries starts with your emergency response plan. All right, so the time to think about this is right now at this presentation. If you have a yard, like I said, you are a battery recycler and you're getting this stuff into your facility. So consider what happens with batteries that come into your facility, regardless of whether or not you intend to get batteries on your facility. You should have engagement with your local fire community, your AHJ, about where batteries may be where batteries are if you're collecting them intentionally. You need to consider a number of different things. You need to consider not just lithium-ion batteries, but you need to consider mixed batteries. Because when batteries come into your facility, oftentimes you're not just getting lithium-ion. You're getting alkaline. You're getting nickel metal hydride. You're getting small-scale lead acid. So the batteries that are coming into the recycling streams are oftentimes mixed, and you can put yourself in a tough regulatory position if you don't have a plan in advance for what you're going to do with things like mixed batteries. You also need to have something in your emergency response plan for damaged batteries, because ultimately it's important that you consider that a battery is not a battery, is not a battery, is not a battery. That a battery can mean a lot of different things, and it is incumbent upon you to keep your employees safe and to stay compliant, to understand what to do with a variety of different types of batteries. And then incident response, drills are one of the most powerful things we can do with our employees. So for people who handle and sort batteries, consider whether or not you have a scenario that you have, and we do this with some of our sorters, a red brick that's a fake battery that you put into the packaging if you're intending to get batteries. And that's the one where it comes in and the employees know, if I get this and I see the red brick, that represents a flaming battery or at risk or something smelling, right? So it's one thing to empower your employees to know how to identify a problem battery, but are you training your employees in what to do? What is your site-specific emergency response plan? Where do we put the battery? How do we get our employees? And because for anybody who's ever done drills like this, even though it's clearly not a battery and it's clearly not on fire, that same endorphin rush that people go through when they see the red brick and an act that is really powerful in empowering people to be able to handle things that are problem before the actual problem batteries get there. All right. So mixed batteries. What do we do with mixed batteries? The problem with mixed batteries is you have to get them off of your facility. If you just throw a bunch of batteries into a drum, you will not be in conformance with the 49 CFR, so the HMR, the hazardous material requirements, the regulations in the United States for shipping batteries. You can't just throw a bunch of different UN numbers in a drum and then ship it. So you need to have something specific for managing mixed batteries. So Calder Cycle has worked in conjunction with a number of different people to come up with some solutions. So I would encourage you to see, and we're not the only ones that are out there. Other people have things like this, but this is a solution where you make essentially a battery parfait, and you can just throw in some batteries, throw in fire suppressant. We actually did a test with ESA at their burn lab in Ohio, and we burned in this solution a 420 watt-hour weed eater battery. So a leaf blower battery. So this is about e-bike size in this drum with other mixed batteries completely compliantly. Now, the battery burned inside the drum. It off-gassed in the overpressure vent, but it didn't get hot to the touch on the drum. You could have literally sat on that drum while that battery burned inside it, right? So we're managing both the environmental hazard, we're managing the safety hazard. We're also ensuring that we're going to be safe from a transportation compliance standpoint. So mixed batteries need something specific that's made for mixed batteries. Damaged batteries, similarly, you need something specific for damaged batteries. So consider too that when you say a damaged battery, what is a damaged battery? So a damaged battery can be something that's small. So this is what we're going to put those batteries that we burned outside with San Diego Fire Department in. You need something specific if you've got a damaged e-bike battery, because once a battery gets over 300 watt hours, which kind of feels arbitrary, you've got to have some different regulations for it. And then also, what are you going to do if you're collecting large amounts of batteries? All right. Handling and storage. Next tip for handling and storage. It's always a good idea to ship batteries in containers that are approved for shipping. So 2024 International Fire Code has some specific new regulations, and one of the regulations says that batteries are permitted to be stored in accordance with DOT shipping requirements. So if you want to be compliant with the fire code and the emerging fire codes, storing batteries and things that are made for shipping batteries is a good way to do that. All right, regulatory requirements. 3 things that you want to go through here you want to consider. The first one that you want to consider is waste generation. Next one you want to consider is fire code. Next one you want to consider is shipping. Now, they're actually regulated by 3 different agencies and groupings of agencies. Waste generation is regulated at the state level with federal baselines. Your fire code can be state or local. The IFC is a model code. It hasn't been adopted in many jurisdictions. And then the shipping regulations are federal. There's no such thing as state level dangerous goods shipping regulations. So things to think about with your waste generator status. Batteries are not the same as scrap metal. If you just collect ferrous and non-ferrous, you may not even have an EPA site ID. If you are getting batteries intentionally in your facility, that's something that you're going to need to do. So be aware that there are regulatory rules if you trigger a waste generator status, a small quantity generator of hazardous waste, a large quantity generator of hazardous waste. If you're intentionally collecting batteries, be aware of your waste generation status. Batteries with an intact cell casing can be managed as a universal waste. But there are still regulations. Just because something is a universal waste doesn't mean you can be all higgledy-piggledy with it. You still have training requirements. You still have record-keeping requirements. You still have requirements for signage and segregation, right? So, and they're not complex if you know what they are. So engage with people that work specifically in this space and know what they are. Next thing you need to consider, you probably need an EPA site ID. Right? That's your starting point. We've seen people in the battery space that have been operating for years and haven't even gotten an EPA site ID. You're starting off on the wrong foot if that's the position you're taking. All right. The next thing that we need to consider after waste generation is we want to talk about our fire code considerations. Just go ahead and give me the full slide worth of bullet points here. All right. So 2024 model fire code has some specific lithium ion storage rules specifically for waste batteries. Your fire marshal, your AHJ, authority having jurisdiction, can shut you down even if there's not a specific violation. They can pull your certificate of occupancy. New York City actually issues what are called seal and vacates, where they say, you know what? No more. You can't do this. You are creating a hazard that's no different from a meth lab. If you're collecting more than 2 drums of batteries, so about 600 pounds, there are different regulations that you need to consider things like fire rated rooms, spacing, suppression, right? Now, here's the caveat to those previous 3 bullets. The 2024 code is a model code. It has not been adopted many places. It's got regulations in the state of Washington that are enacted. New York City has got a lot enacted. But following these regulations, this model code, even if it's not the law of the land where you are, is still a best practice. It also indicates a signal of commitment to your AHJ, who you want to engage with at the outset. Similarly, too, you wouldn't have hot work being performed next to propane tanks, so you need to consider that there are specific actions that you need to take for storing lithium-ion batteries. All right, so the third thing that you need to consider is transportation regulations. Next slide. All right, so go ahead and fill this one up here. So things that come into play, classification, what do I have? Shipping papers, how do I communicate to the carrier what I'm shipping? What type of marking needs to go on it? There's 3 more. Keep going. Yep. What type of label goes on it? What is the emergency response? What is the training? These things by people who work in this space are called subparts C through H of Part 172. This is kind of the baselines for shipping any type of dangerous goods. All of this stuff comes into play. But really the thing that's specific is packaging. What are you going to put lithium-ion batteries in? So now, as you can see here, packaging can mean a lot of different things. It can mean drums, jerry cans, boxes, bags. It can mean steel, aluminum, open top, closed top, right? So the packaging part gets pretty confusing pretty quickly. So some things to consider. Lithium-ion batteries, go ahead and fill this one up, please. All right. All right. So there's 2 things that I want to touch base on that everybody needs to be aware of. And this is mainly meant to bring awareness so that there's no unknown unknowns. When you're looking at disposal and recycling, if your battery is undamaged, there is relatively easy to meet regulations. Strong outer packaging doesn't necessarily need to be UN rated, but you do have to have short circuit protection. However, next slide and fill it up, please. If you are shipping a damaged battery, a whole different set of regulations come into play. If you're shipping damaged batteries, each battery needs to be individually bagged, and you need to be in packing group 1 drums or crates. So these are robust drums and crates. Now, let's say you're bringing used drums into your facility. the likelihood of having the closure instructions for used drums is pretty low. And if you're bringing used drums into your facility and you think you're going to use them to ship damaged batteries in, a packing group, a UN-rated performance packaging only counts as UN-rated performance packaging if it is closed in accordance with the manufacturer's closure instructions. So there's two things that people consistently get dinged on when it comes to hazmat regulations. The first one is training, because it's really easy to come and say, hey, let me see your training records. All right, you go, I got no training records. All right. The next thing that it's really easy to get dinged on is closure instructions. Oh, you got these drums here? Oh, this is ready to go. Hey, can I see the closure instructions for these drums? So you can reuse drums. There are provisions in the regulations for reuse, but just be aware, higgledy-piggledy drums coming in getting reused is a recipe for noncompliance. All right, go back one slide here. And also, damaged batteries need to have an absorbent fill material. You can't just individually bag damaged batteries and throw them in a drum and think that you're good. All right, next slide. All right, how do you know if your battery is DDR? This is a $24,000 question that we get a ton, the EPA gets it a ton, the DOT gets it a ton. How do I know if my damage is battery? Well, what the regulations say is a lithium cell or batteries that have the potential of producing a dangerous evolution, heat, fire, and short circuit. So let's dig in a little bit more. About 3 years ago, PHMSA, the Pipeline Hazardous Material Safety Administration, the administration within the Department of Transportation that regulates dangerous goods in commerce, actually provided a safety advisory. So if you just Google DOT battery recycling safety advisory, then this will come up. And this is one of the first pieces of real guidance that we have seen on what a damaged battery is and how do you know if it's damaged. All right. So the DOT said a couple of things. If it's known to be defective and has been recalled by the manufacturer, it's a damaged battery. If it's leaked or vented, damage. If it shows signs of physical or mechanical damage, swelling, all right, so those bloated pouch cells, it's a damaged battery. Discoloration, smell or corrosion, damaged wires, known signs of misuse, right? These need to be managed as a damaged battery. But here's the biggest thing. Last slide. Batteries suspected of being damaged but cannot be diagnosed. You can't just say, God, I don't know what it is. It'll be fine, right? The fines for non-compliance go beyond just the financial cost of the fine itself. It has to do with your reputation. It has to do with your relationships with your carriers. It has to do with burning facilities down. It has to do with the damage that you can cause to the public. All right. Now, there's something else that I want to touch on. So see how this says potential? Next slide here. Damage versus a forbidden article. If you have something that you know is just acutely hazardous and about to go off, that's a forbidden article. You can't ship it. Lithium cells or batteries that are likely to create sparks that are dangerous or generate a dangerous evolution of heat. We're actually working with ESA right now on sending somebody to Hawaii to dehazard some batteries so that they can be shipped, because right now they're in such an unstable state that they can't legally be shipped, one, and two, no carrier will take them. Next slide. All right, last thing to touch on is packaging. All right, so go back. Okay, so these are both packing group 1 drums. These are both allowed by the regulations. Next slide. Okay, but if you got a lot of batteries, you go, hey, do you know what? It's these plastic drums. I can get a lot of these. These are pretty cheap at packing group 1. Next slide. Okay, now this was an EPA cleanup. They call it Lakes Parkway, if you ever want to see the EPA cleanup on it. This packaging solution was signed off on by 4 DOT PHMSA enforcement officials. Packing group 1, individual bagging, fill material. Right, so just being compliant, you need to understand the risk profile of what you have. So keep going. So you can see the battery melted right through the plastic before the fire suppressant had the opportunity to work. All right, so what do we do at Calder Cycle when we work with ESA to do these batteries? We actually test for containment, because containment is not a portion of the regulations. This is that one drum I mentioned, throw the batteries in, as I said, 400% NMC, 100% state of charge. So 2 PSI vent plug. So this way you don't get a dangerous buildup and accumulation of gas. And you can see that battery was fully consumed in that. Keep going. All right. So all charred up, all burned. You can see where we gassed through the material. Our fire suppressant melted around the individual cells, but as you start to dig through it, everything else in the drum was not. So fill the slide up. All right. So on the left is the heat graph of the batteries itself, and you're just over 1,000 degrees on the ignition cell. On the right side of the slide are the temperature sensors from the outside of the drum, and we didn't get above 50 degrees C on the outside of the drum. So ASTM C1055 is guidelines on contact burn injuries. So surface temperature can't exceed 140 degrees, and that standard is 5 seconds will give you a burn. And so that drum with a 420 watt-hour battery in it didn't get above those thresholds. Same kind of thing, but with a smaller drum, we actually did 460 aggregate watt-hours in it. It melted the liner, it vented, it absolutely burned to smithereens on the inside of that drum. So you can see fully consumed here. No flames escaped it, and no material projectiled outside of it. Right? So this is the kind of thing that you need to engage in or partner with somebody who engages in if you actually want to manage the safety associated with your batteries. All right. So let's keep on going. Solution side, fill this up here. So the takeaways: proactive plans for handling and storage. Run incident drills with your staff. Know your waste generator status and the associated obligations. Know your local fire code. Follow the FC model code, even if it hasn't been enacted. Make sure your people are trained. So in the 49 CFR training, before they ship lithium-ion batteries, packaging matters a lot, and then ultimately have appropriate packaging on hand before you need it. The last thing you want is batteries accumulating and you don't have anything to put them in. All right, I really appreciate it. I know it's a ton of stuff to go through. Happy to connect with anybody afterwards if there are any specific questions. Thank you so much.
Let's give one last round of applause for Eric and Chelsey.
Good job.
All right, we've got the next portion of the panel on up here. I'm trying to see how y'all can see most of us. So I really appreciate all of you coming out to this session. Battery proliferation is rising across the board. If you were in the battery policy session with EPA, I think we did a bit of a raise hand. How many people have headphones with a lithium-ion battery in them right now? How many people have got their cell phone? Just raise your cell phone. I know all of y'all got one. How many people have their laptop with them? How many people drive an EV or plug-in hybrid? Batteries are just about all over. And I realized I wasn't raising my hand. I've got all of them but the plug-in hybrid or the EV. So batteries are commonplace, which means those handling materials at end of life are getting them. And you want to know what to do about them. So we've got a great group of members up here who represent various parts of the battery supply chain, the battery end of life supply chain. So I'm just going to go down really quickly and give them about a minute to introduce yourself, what role you play in the supply chain,
Sure.
And where batteries are impacting you.
Hi, my name is Scott Miller. I'm General Counsel for Sims Metal, the North America Metals Division of Sims. And so my role is I get involved in a lot of battery-related aspects. At the highest level for dealing with a lot of battery legislation at a variety of states and at some point in the federal government. Also through dealing with incidents that occur, battery fires that may occur, or procedures that we take to prevent fires and to determine what are best practices for us in terms of keeping batteries out of our inbound material.
Thank you. Good afternoon, everyone. Jason Muccioli. I'm the Director of Business Development for Send Elements. So for those that aren't familiar with the Send Elements, we're a battery recycler, and we use recycled batteries to make new battery materials. I handle all of the feedstock or battery scrap that goes into our shredding facility down in Covington, Georgia. Before Send, I also worked at LiCycle, which is another battery recycler, so I've been in this industry for several years.
So my name is Susan Epps, and I'm a corporate safety manager at Waste Connections. And my role in this is I focus on MRFs, and I have for about the last 20 or 30 years. Never thought I'd end my career as worried about batteries. I thought there were other things, but batteries and fires that are occurring in our facilities. So that's my role in this supply chain, is trying to figure out how to see them and what to do with them when we do see them.
Thank you all for being here. So we know that battery-powered products aren't new. They've been around for years. It's just the rise in that we're starting to see over the last decade and into the future. How, and maybe a better way to phrase this is, what's the biggest difference in how you handled batteries you may have received 5 years ago versus the inflow that you're seeing today? Did any of your practices change?
So I would, in a word, in a phrase, all of our procedures have changed. 5 years ago, this issue was barely on our radar. Probably 3 years ago. I remember, in fact, going in November 2023 to a battery conference at ReMA sponsored in South Carolina, and there were two tracks. One track was small and medium-sized batteries. The other track was electric vehicle batteries. I said, well, why are we even having this first track? All the attention from us and a lot of others was on EV batteries. The world is standing completely on its head from that point. So I'd say somewhere around 2023, 2024, we transformed all our programs and focus, and now are 100% focused on small and medium format batteries and their role in our metal recycling business. I should mention, by the way, that Sims, we have about 70 locations throughout the United States. So this is both from the large shredder processing facilities all the way through what we call feeder yards. So we get these batteries. We deal with the situation in pretty much any circumstance a metal recycler could address.
Yeah, so for Ascend Elements, we focus primarily on automotive batteries, and over the past 5-10 years, the automotive market's become so much more complex. If you look back about a decade ago, most of the OEMs had one or two EVs. So using GM as an example, they had the Chevrolet Bolt. And then you look today, they have an entire portfolio of vehicles. So each of their offerings is electrified. Some of the models have multiple batteries. So they'll have like an NMC large battery, an LFP smaller battery. So you're dealing with different chemistries, different models, different sizes. So this has caused us to drastically change the way we bring in batteries. We put a lot more effort on the front end to understand what materials we're receiving and how they're packaged. And this has caused a lot more work on the front end to make sure that we're safe when we receive this material.
So we've seen a lot of changes in the recycling industry from a single stream processing standpoint. So that's one of the biggest things we've seen is everything comes in one truck. Unfortunately, when it all comes in one truck, everything's mixed in there. We can't see what's in the bin. So it's really, I would agree with Scott, everything's changed. And the real focus for us as a company, as industry, I think, is to identify that battery at the source, the closest to the curb or the closest to the home as we can, and identify where it goes.
Thank you. So you've all talked about some shifts that you've made to handle the inflow of batteries that you're seeing, whether it's at the curb from a consumer or whether it's in a metal recycling operation or whether it reaches a battery recycler. I wonder, what sort of technology have you all invested in or have you considered investing in to help mitigate some of the safety concerns surrounding these batteries, whether it's identification, whether it's fire suppression? What are you looking at? And I'll say this, if anyone in the audience has a question and wants to come up, I encourage you to do so. We have this member-led second part of our panel for a reason, so you all can learn from each other. It's such an emerging area, and what everyone's doing is so different based on their capital means.
So for technology, what we're looking for is a magic bullet. In other words, be able to find a battery and a needle and haystack for us, which means finding a battery when you have a load of scrap. So the first thing you think about is robotics and AI to identify. We've tried all that for other things. We tried that for propane tanks, for instance, and other incredibly difficult. Now AI has changed it and made it more likely, but I think we're a long way, in my limited view of this, we're a long way away from achieving that particular magic bullet. One thing that's hugely important is when you identify the battery is for us to use a heat sensing camera like a FLIR to at least see what the state of the battery is to make sure what's the threat to us. And then other technologies that others have mentioned. I think Eric mentioned about. You mentioned about fire blankets. Something I will mention that there's a bit of confusion on that because I went to a presentation at the Maryland has a commission on lithium-ion batteries, and they had several firefighters talk about what they do. And I was in the audience. I'm not a member of the commission, but it's open to the public. So I'm the public. And I was confused because we have looked at ourselves at things to keep fires, once there's a fire, what to do with the battery. So we've looked at dump tanks and we have the blankets and so forth. But we were told, I was very surprised that the person told me that just when the battery is in a state of likely to ignite or go into thermal runaway, to just let it do its thing and don't touch it, to segregate it from everything else, leave it alone. So it's not technology, but the state of practice is changing and it's somewhat confusing sometimes. But that's what and number of people who are firefighters or in that chain confirm that. So that's we're just keeping out with the current technology is important, just to know where the state of the art of technology is and understanding of fires.
Yeah, so things that have changed in how we've dealt with technology. One of the pictures Eric showed is during transportation, the one semi, the back blew up from the drum. Again, getting back to communication, we've gotten a lot more involved with how material, not only what material we're receiving, but how it's packaged, and not only the type of packaging used, but how the material is put into that packaging. And that's become very critical, as we've seen several instances where there's been issues during transportation. And then similarly, during the shredding operation, there's been instances where fires have occurred throughout the industry and at our facility, and that's caused us to put in many layers of safety or different types of fire suppression systems to make sure that we're able to handle different scenarios when they occur. So we have thermal imaging, we have different types of water, CO2, and nitrogen suppression on our lines that will automatically kick in if we do have some type of event. So much more safer on the front end and during processing of the materials when we receive them.
Similar to the other two, I would say Visia from an X-ray technology, Steinert from a technology standpoint, from an X-ray standpoint, are able to identify the batteries now. There are other people, Van Dykes and CPs, and those people are coming through from a single stream processing standpoint that can be used. So there's a lot of technology out there. Question is, what do you do when you find it, right? Do you pick it up and throw it down a chute? That's not a very smart idea. So there are some questions about that, but both of those companies, and others short on their tail, are coming up to the point where they can identify batteries in the stream for us. The other thing is, from a fire protection standpoint, I use Fire Rover at our facilities, and I know Waste Management does, and they are extremely successful. They put a fire out for us at least once a week at one of our facilities. So they are well worth the extreme costs. They're very costly, but they are well worth not burning down a facility. Unfortunately, we had the bad luck to burn down two facilities, and they were both in bunker fires. So we went after some bunker suppression, which is we use a specialty company to design suppression systems in the bunkers in addition to the sprinkler systems. We found our sprinkler systems do us no good. So we've had to come in after meeting building code, and design specific fire suppression systems for our situations. So I highly recommend working with someone like that, and also working with Fire Rover will do good for bale storage of open areas, piles, things like that, processing equipment under conveyors, bunkers, and things like that. The specialty fire people can do a really good job for you, but there are several people out there that can provide great solutions.
So Susan, you made a comment about investing in some new technology that currently exists. We know as a whole, the recycled materials industry is incredibly capital intensive. For those who may not have those resources or access the new technology, regardless of pricing and where it costs, what's a low-tech safety measure that these folks can employ that will matter no matter what?
Training, and drill. You talked about the red brick theory and things like that. Some of our loader operators are so good at removing smoking anything at this point that they'll call and they'll say, well, we got something and Fire Rover didn't see it. What's wrong with Fire Rover? Because they're so good at seeing. So I would say that employee training and teaching those hazards that we talked about, the recognition, using their senses to see that, and training those employees. Because what we do know is that facility, whatever facility you're working in, that's how they make their livelihood. And train them to protect that facility, and they will grab onto it like you can't imagine. I've seen so many people really, just because that's their livelihood and that's their home, most of them spend more time there than any place else. Training and drilling.
Thank you, Susan. Scott?
I would like to, first of all, 100% agree, but I would also add that for us, the most important low-tech thing you can do that the training and drilling should go towards for us is inspection. We cannot, I can't stress enough how the individual manual inspection, how important that process is. Training on how to not only to deal with the batteries, but how to find them. Because it's, again, a needle in a haystack and you have to have all these cues. It could be a single battery, a small button battery. More likely, we found battery packs. And they remember, they're mixed in with things that people are discarding. So you really have to know, they're not going to look like something that's in a picture book. So they're going to be, they're going to be beaten up sometimes or discolored in some way. So inspection is critical. Now, what we found also, based on hard experience, unfortunately, that, and I say this with an interest of really making a difference. We've decided we've actually segregated our stockpiles now. So we have traditionally have a separate stockpile for car bodies and a pile for what we call light iron and everything else. We now have a third stockpile. Whatever material we get from a MRF, we separate out because we had found, given the chain, remember the chain is from the individual discarding the material to the MRF or the landfill, in our case to the MRF, and then the MRF to us for the metals. And it's not the MRF isn't doing its job. It's the job of the MRF is a thankless one and it's one impossible. We're all dealing with volumes of material, and so if it's missed at the MRF, we're the last line of defense before it goes into the recycling stream or worse, ignites. So it's inspection of that. We actually have done a couple of things. We've actually expanded our inspection area, and we've expanded the number of people who are inspecting specifically to try to do everything we can on the inspection front. I would just, can I add one more thing?
Mm-hmm.
Low tech, getting a standard procedure. And we had some excellent presentations about things to look for and things to do with packaging and handling. I strongly recommend putting them into a standard written practice that you can train against, because you want to be ready when things happen. You not only do you want your people ready, but you want all your procedures and your diet, everything ready to go so that you're ready to deal. So we have standard practices which include the drums we use vermiculite as a base. We have the separate drums for the different types of batteries and so on. And it's just being prepared. It's kind of the old Boy Scout phenomenon. But that generally, those are all low tech things that are really essential, at least from the metals side, to keep these batteries out of our stream or find them when they're in the stream. Thanks.
Yeah. So we've done a lot of talk on how to enhance safety procedures within your own operations, and safety doesn't exist in a vacuum, right? It's informed by education, partnerships with your fire safety professionals, working together with other folks in the materials ecosystem. So, and that goes all the way to manufacturers, to consumers, to haulers, and then to recyclers, right? Where do you see the biggest gaps, either in communication, in partnership, in education, related to battery safety?
What's that?
Yeah.
So to me, the number one place for the gap in communication is from the members of the public to the MRF to the recycler. What we advocate in legislation is that most of the focus should go on educating the public and make sure that's well funded, because there's a huge gap between what they think they should be doing and what they're actually doing. Granted, you need to give them options, places to go, but you have to alert them how serious the problem is. And unfortunately, in certain places, that seriousness has been expressed, like in New York City, when the fire chief gets out and says, we've had numerous deaths because of of fires caused by batteries in your apartments and homes. That's a wake-up call that will, unfortunately, for very bad reasons, inform the public. But that's the biggest gap that I've seen is stopping the problem before it becomes a problem at the upstream most point, which is in the members of the public.
Yeah, very, very similar. What we've seen from the recycler side is, when dealing with either newer companies, startups, or smaller aggregators that just aren't educated on the topic, some of them don't even know what type of batteries they have. They don't know the proper packaging or other requirements. And so there's just a big gap there. And for us, part of what we do is just educating these companies so we don't have a thermal issue when we transport or receive the material. And that's become very crucial for us. But there's still a very large gap when dealing with someone new to this industry that doesn't really understand what they're dealing with.
Same thing. It's a consumer issue. So if you say it's recyclable and you have two carts and you have one that's garbage and you have one to recycle and you tell people it's recyclable, they're going to put it in recycling. And they're always going to do that unless you make sure that they know that it's not recyclable. It is recyclable, but not in that cart, right? So that's part of the problem. But I think that the real key is having very local places to deposit these batteries, whether it be, there's a lot of people coming on board. AT&T's come on board. I think now Staples, Best Buy, Home Depot, a couple of people, but you really need some place like your local supermarket that you go to, or your local, like a Walmart, or I don't know what the local supermarkets are here, like a H-E-B in Texas, and a Walmart and those kinds of places. You need it where somebody goes convenient. They're not going to go out of their way to dispose of it when I can walk out my door and throw it in a cart. So that's, I think, the issue. It is recyclable, just not in that cart.
All right, so before I turn to the audience, and I encourage you, if you have questions, please stand up. Please don't shout because we may not hear you. The room does echo. Just head on up to a mic. But what is like one last piece of advice? You each have around a minute, so we'll keep it rapid fire. You'd like to offer to those in the industry who are just starting to develop their battery handling processes or enhancing their safety protocols?
Okay, so number one is be prepared with the things we're talking about here in terms of everything from inspection through disposal and everything in between. Two is get guidance where you can get it. There's many good resources. The fire departments, you have the battery recyclers who can give you the full panoply of packaging and handling and shipping requirements delivered to you. I mentioned that preparation includes not only the inspection, but the training and the SOP and so on to do that. So it's really just be ready, just like you would with any safety incident. Be ready, be prepared, practice, and when something happens, you won't be kind of caught flat-footed.
Yeah, I agree 100%. Just to expand on that, like Call to Recycle is a great resource for the industry. So they have a lot of very valuable knowledge on their website. The whole team's very knowledgeable. Great resource. All the recyclers, so not only Ascend Elements, but all the other recyclers, their teams are well versed in packaging, logistic, all the requirements to transport batteries. So just rely on the companies that are already experts in those areas.
I would say that there's no one solution that fits everybody, because if you're rural, if you're in a big city, whatever it may be, to partner with the people in your area and develop a local solution, because the local solutions are the best solutions for you. The ones that are 10 miles, 20 miles of your house.
All right, any questions for our panelists or for Eric and Chelsey? Everyone's got this down, right? Mark.
He's not allowed to ask questions.
You might, Mark.
We did find, surprisingly, we separate out, we have a paper recycling side that we manage. We found batteries in the paper stream. Didn't expect to find it in the paper stream. In fact, in one case, it was with very bad consequences. We find it in the heavy melt material, which is not expected because usually you expect it to be the material that's going into the shredder. Heavy melt, for those who don't know, it doesn't go into the shredder. It's either cut mechanically or just separated in the yard. So we've seen, and it could be, frankly, you can almost pick any place where there's a place to put a battery in, either to hide it because you want to get rid of it, or because it falls between the cracks. Is an equally likely chance you'll find a battery somewhere.
And just to add sort of different take on that, even though we don't deal with consumer batteries, focus on electric vehicle, one of the big challenges we deal with is how to classify batteries as DDR. So Eric talked about this. There's sort of a gray area, or was a gray area, on what's considered DDR, and a lot of companies we deal with don't know the difference. So sometimes we'll get DDR batteries and non-DDR packaging, and there's a reason why there's much stricter packaging requirements for those batteries. So a lot of these companies will try to avoid that, but there's these regulations for a purpose. So again, for us, trying to identify the material we're receiving beforehand is very critical from that aspect.
I would say from our business, one of the things that we're seeing that we didn't expect to see are vapes. We're seeing an enormous number of vapes, which we didn't anticipate, which presents a whole different kind of turn on this. So,
if I can mention one more, I just realized one thing I can't overlook is how many batteries, even in a non-electric vehicle, are in a vehicle. So that's another surprising place. Good question. Thank you.
How about your home security system? How about if you've updated that one lately? That goes all in the trash. Yeah. Yep.
Okay, any last minute questions for our audience, or for our panelists from the audience? Okay. Well, if not, before I give them a round of applause and everyone stops listening, we have we had 4 total, but 2 other battery burns sponsored by Call to Recycle and the San Diego Fire Department. They're going to be outside in the safety pavilion. I know this group that's here today is interested in safety, or you would not be in this session. So make sure you go outside, take a walk through. All these folks have very little stake within the recycling industry, but they want you to be safe. And so they've got a lot of resources for you, for your employees. The 2 battery burns tomorrow will be at 10 a.m. and 1 p.m. outside in Safety First Plaza. You can get to it by walking out onto the patio and to the left and down the set of stairs. You can also find it if you're headed to the exhibit hall. But with that, thank you all for coming, and let's give a big round of applause to our panelists.